Right, let's have a go at 17 then. We've got this thing here, y equals ln of bracket 3 over x to the 5 to the power half. We mean log of this object to the power half. So in a sense, you can think of it as having a bracket like that. That's what we mean when we write that, right? Otherwise we would put brackets somewhere else. So that's what we mean. I'll just get rid of that 2 brackets and then we can start the problem. Okay, so let's start the problem then. So we got a simple object to a power. So you know that, don't you? Power rule, here it is here. So this little chappy in the air is nothing in the way. It's just a simple object to a power, jumps down to ground level. So the half is the power, it jumps down to ground level. So we can write y equals a half ln 3 over x to the 5. Yeah? Now you've got a half lots of this thing. You've got divide, haven't we? An object over another object with divide rule. Here's the divide, you minus top take bottom. So we're going to get more than one term that can come out from this. So let's put a little bracket, a little brace, and then we'll work out what's inside half lots of this, yeah? Log n of something divided by something else is divide you minus top take bottom, so it's ln of the top minus ln of the bottom. Agreed? And then what we can do is we can expand the bracket now. So should we do that? Why not? Because it's immediate, so let's do that. So 2 lines, 1, 2. So the first line then is a half log 3, and the second line is minus a half lots of ln x to the 5. There we go. Good. Now this thing here, the first time, we don't need to worry about that because you can tap that in a calculator, you'll see it's a constant. So that's taken care of. This is the little snag here. We still need to tidy this up a bit more. It's a simple half lots of log of something to the 5. Again, it's the power rule, isn't it? Log n something simple term object to a power 5. So let's use that rule. And we can write down half log 3 minus. The 5 comes down then to ground level to be with the half, so it's 5 halves, or 5 over 2 we can write. And then x. There we are. That's tidied up. Now we can do the differentiation then. dy dx equals this, as we said, is a constant. So it differentiates to 0. There we go. Minus 5 over 2 log x differentiates to 1 over x. So lots of 1 over x. So let's tidy that up. Dy dx then is equal to minus 5 on top over 2x underneath. There we go. That's the derivative. At x equals 4 is the input. Let's work out dy dx then. It's minus 5 over 2x, which equals, and then we input the value 4, don't we? So wherever we see an x, little bracket around it and overwrite it with 4. 2 4s are 8, so it's minus 5 over 8. There we go. It's the answer for 17. Job done, yeah? So we had to unwrap it, unwrap the log, object to power half. So that simple object, power half, the half can come down. Then we had a divide, simple to object on the top, object on the bottom, divide you minus, top take bottom, but it was a half lots of, and this was going to produce more than one term. So I put a little brace, little bracket around it there. Expand the bracket then, because there's 2 terms inside, and you'll get that. And then this is just a constant. Tap it in the calculator and see that's the case. And this, we can bring down the power, can't we, using the power rule. 5 over 2 log x. Then now we've got it tidied up. Everything is in the form that's on our simple list of derivatives here. So we can differentiate. That's a constant, goes to 0. Minus 5 over 2 lots of log goes to 1 over x. That's it. Input the value then. And then we can evaluate the derivative at that input value. Minus 5 over 8. Good. Let's move on then to 18 next, yeah?